Hi class. I cannot be with you in class today because my 3-year-old is incredibly sick, and both myself and my wife have been basically ping-ponging and taking turns taking care of her. Uh, Sick Kids Hospital had a 6-hour waiting line, and so you can imagine what that has done to us as a family yesterday. So please forgive me for teaching you through a video. Also, don't give the substitute teacher a hard time. Today's lesson is going to recap 5.3 by giving you a special Ferris wheel question. And on that note, after we do the Ferris wheel question, uh, I am going to link it to chapter 5.5, rate of change. Anywhere from this 5.3 all the way to 5.4, whenever we get to around the 10:15 mark in the morning, I am going to ask the substitute teacher to take you out for a walk, but um, that's ultimately going to be left at the substitute teacher's discretion. If it is someone that is on call from Northern, they'll be very comfortable, but some supply teachers will not be comfortable doing that because it might be unfamiliar. I will leave all the instructions, but ultimately that is to the substitute teacher's discretion. Don't give the substitute a hard time if they say, we're going to stay inside, okay? There could be a variety of reasons why, so just listen to them, all right? So let's do this. Mr. Kim's super galactic Ferris wheel question. There might be some jumps here and there. This video is also going to be posted on Brightspace, so don't feel like you're missing out if you don't copy frantically, okay? I'm going to pause the video and type out the question. All right, that was like a good 5 minutes, but for you probably would be an instant. So here is my super Ferris wheel question. Mr. Kim dreams of a one-of-a-kind Ferris wheel. The Ferris wheel will be 50 meters in diameter, where a part of the ride takes the carts into an underground aquarium. The passengers get on from the aquarium, the lowest part of the Ferris wheel. The cart reaches a maximum height of 28 meters above ground. One rotation around the wheel takes 60 seconds. State a sinusoidal equation that correctly models the height of the Ferris wheel in terms of time in seconds. So while you're working on that, if you're having a hard time, that's okay. I'm going to ask the substitute teacher to pause the video. Just give 1 minute exactly to see if students can at least identify what the A, K, D, and the C might be for this question. And while you're doing that, I am going to try to illustrate what is going on here. Okay, so here's our little fishies, right? Here's a shark. Okay, here's an octopus. Okay, 8 legs, whatever the case may be. The Ferris wheel is going to look something like this. Now, if you can illustrate this Ferris wheel on your own, even better, but that's okay. Okay, so it would be a height of 28, but you know that the radius is going to be 25. The passengers get on at the lowest part of the Ferris wheel, and let's pretend it's going to rotate. Okay, and yeah, so the teacher can pause the video, giving another minute. Okay, and the minute, I'm assuming the minute is going to be done soon. I'm going to get to it. The Ferris wheel is 50 meters in diameter, which would automatically tell you that the amplitude is going to be 25. Whether it's a positive or a negative, that's something that we can calculate later. The K value, that is going to come from how quickly one rotation is going to pass. So we'll get to that very soon. The C value, might seem a little bit confusing. Some of you might have, just strictly memorized how to calculate what the C value is by, taking the highest point and with the lowest point and then dividing it by 2 or whatnot. Um, that is one way of doing it, but if you think about it in a different way, you know that the transversal axis of a sinusoidal curve should be located where the central axle of a Ferris wheel is. So in that case, how high is the central axle from the ground? Well, it's going to be 3. So I'm going to say the central axle is a plus 3. That's where the C value is. Okay, and the reason that makes sense is, remember, my function is going to be in terms of height. Sorry, it's going to be in terms of t. So when I say plus 3, that means the central axle has a height of 3. Okay, let's do k. Let's do d. D. It says that I am going to be starting from the lowest point. So if I think about it in terms of a graph, that wasn't very clean. If I think about it in terms of a graph, it's going to be something like this, right? So if you want, you can write this as a sine curve saying, hey, this is where my sine curve is going to begin. So it's going to have some kind of a horizontal or phase shift. And then I am going to finish here. And that's my one curve. In my opinion, an easier way is just pretend that's where you start, right? Pretend that's where you start right there, which is basically the same as a cosine curve, but vertically reflected on the x-axis. So that's what I'm going to do, all right? So I'm going to say that the d value is actually, there's no shift. I'm going to do this as a vertical reflection. That's going to be a negative, okay? So hold that thought. K, the K, the wheel, it takes 60 seconds. In other words, the new period is going to be 60. And the old period is going to be 2 pi. So what is K value? Well, it's going to be the old divided by the new based on our formula. It's going to be 2 pi divided by 60. It's going to be pi over 30. Pi over 30. So let's put it together. F of x, rather, h of t. H of t is going to be 25, but it's going to be a negative. Just hold that thought. It's going to be a cosine. My k value is going to be pi over 30. My x, or my t, will have a phase shift of 0. And my c value is a 3. And of course, because I start at a minimum instead of a maximum, it's going to be a negative 25. There it is. If you did choose to start the curve in the middle, in other words, if you choose to start the curve at, I guess, as a sine curve, in other words, you wanted to write this as sine, what would the phase shift have to be? Well, normally a phase shift to the right by a quarter of a period would be pi over 2. However, this wavelength, or sorry, this period, this curve does not have a period of pi over 2 pi. Right? The period is 60 seconds. So from here to here is 60 seconds. So if I were to shift over a quarter of that, what would that be? It would be 15 seconds. There it is. Okay. Very important. Either of these answers would be correct. Anyways, yeah, I'm going to use the easier one. I'm going to use the cosine one. Okay, what do I mean by using? Well, I'm going to link this to rate of change. If this is the equation that you were given, what if I asked you as a connecting piece, what is the rate of change, the instantaneous rate of change at 10 seconds after getting on the ride? Well, you know that rate of change by formula is going to be the change in the y values as the x values change. Or in this case, it would be the change in the height over the change in the time. More specifically, it would be the height at 10.001 seconds minus the height at 10 seconds divided by the time at 10.001 minus the time at 10. So now might be a good time to take out a calculator. I'm going to erase this picture and calculate it with you. I'm also going to choose the cosine curve instead of the sine because it's just less calculations to do. Let's do it. The height at 10.001 is going to be, well, negative 25 cos pi over 30 times 10.001 plus 3. Make sure that your calculator is set to radians. Otherwise, it'll be in a hot mess. Minus 25 times cosine divided by 30 times 10.00 plus 3. All right, so the height would be negative 4.4977. What is the height at 10? Well, do the same thing, but negative 25 times cos of pi over 30 times 10 plus 3, negative 9.5. So the IROC at that time would be negative 9.4977 minus a negative 9.5 over 10.001 minus 10. This brings us to a positive 2.30000. What would that be in units? Well, it would be meters per second. What does this represent? Well, the instantaneous rate of change at 10 seconds means right at 10 seconds, the height is increasing by 2.3 meters per second. That's what it means. Okay. I wish around now would be the time I ask you if you have any questions for me. But yeah, I will just expect some questions from email or something like that if you want. Okay, so this is my, I guess, quick review of what rate of change is. For the quiz and stuff coming up and the tests, I just need you to remember how to calculate rate of change, whether it's average rate of change or instantaneous rate of change. Okay, hope that's good enough. One extra thing that I think might be worthwhile doing in terms of transformations is to talk about this equation strictly in terms of communicating the transformations of AKDC. So how would you, let's pretend you get a question and it says, describe these transformations using words. Okay, well, how would we communicate that? Well, in order, it would be, what happened? It would be A, it would be K, D, and then C. Okay, so for A, there are two things that are happening. I would say that there is a reflection on the x-axis, and also there is a vertical stretch by factor of 25. For the K, there is no reflection on the y-axis. However, in this particular case, let's see, pi over 30 is a number that is smaller than 1, and therefore it's going to be a horizontal stretch. Horizontal stretch by a factor of, and what would I be actually multiplying to the x values if this was my K? It would be 30 over pi. Okay, let me finish this. There is no phase shift in this case, and this is a vertical shift 3 units up. Going back to horizontal stretch by a factor of 30 over pi. The textbook describes it in this way, and I will agree with how they do it. If you've had practice so far, or if you've had other teachers, I hope that they taught it this way. You have a choice of describing this as a stretch or a compression. The word that you choose for this should accurately reflect what is happening visually. So pi over 30 is essentially if you remember the chart, the x is going to be multiplied by 1 over k. In other words, x is going to be multiplying by 1 over k being 30 over pi. All the x values are being multiplied by 30 over pi, which is very close to a value of 10. So by a factor of 30 over pi, everything here is being multiplied, right? Factor of 30 over pi. And if you multiply by a number larger than 1, well, what's going to happen to the x values? Well, it's going to get bigger. Overall, if this was a curve, all the x values get larger than it was before, and it will look like it is horizontally being stretched. And so the word here is visually what's happening to the curve. And here it's what are you multiplying? What is multiplying with, well, what is multiplied to the x values? That's going to be a big refresher from grade 11 stuff. Yeah, there it is. At this time, I am going to, again, just remind, if it's close to 10:15, then the teacher can send you for a walk break. Otherwise, I'm going to go straight into examples 3, 5, and 6. Okay, here we go. So this is going to be example 3 from the handout. I'm also going to be doing example 5 and 6 all in a row. It might be a little fast, but know that, again, this video will be uploaded, so you can watch it again and again as you please. While you're getting ready and taking out the handout and getting yourself ready for this, I want to introduce this question as example 3 as the first time you are going to see a double angle formula. Please pay special attention to how I deal with it, because you'll be tempted to do some other things. You have to get into the habit, or you have to watch out for something. Okay, so put a little star next to that if you want to. 2 sine cos equals cos 2 theta. This is not a trig identity, but we can use identities to help simplify this. Remember, the goal is to isolate the angle to the best of my ability. In fact, if I could turn all this into a single trig ratio, like sine theta equal to 1 or something, you can figure out what the angle is. So is there a way to simplify this, to turn it into one ratio? Well, check it out. 2 sine cos is the same as sine 2 theta, thanks to the double angle formulas. Okay. Next, I am going to continue simplifying, or continue sort of solving this. I'm going to divide both sides by cosine 2 theta. Right? So the right side is equal to 1, the left side equals to sine over cos. And what do you know sine over cos as? Since the angles are exactly the same, 2 theta, I can rewrite this as tan 2 theta. And the reason I do this is because sine 2 theta over cos 2 theta, it still doesn't quite help me, right? It still has a lot of different possibilities, a lot of different, I guess, answers that could be possible. And unless you really know your stuff, you'll have to rely on guess and check. It's a little annoying, right? Or a lot of graphing, and it might not be an exact answer. But if I turn this into tan 2 theta is equal to 1, well, all I have to do is solve this, okay? And some of you, when you solve this, may be tempted to do some funky stuff with that too. To make sure you're not doing anything you shouldn't do, I'm going to substitute 2 theta, and I'm going to write that as alpha. No, I might confuse you. Let's do it as beta. I'm going to do it as little b. So tan 2 theta, I'm going to rewrite as tan of beta equals 1. All right. Okay. Going back to this now, uh, apply the 2 sort of mini steps that I asked you to try when solving trig equations. The first being, figure out what quadrant we're in. The second being, figure out what the related acute angle is so that we can apply it to the quadrants. So, part 1, tangent being a positive using CAST rule, C-A-S-T. Whatever angle beta is, it must reside in quadrant 1 and in quadrant 3. So let me put a little mark there to remind myself. Next, if tangent beta is equal to a 1, what angle, sorry, not beta, if the related angle was in fact equal to a 1, what would that related angle be? Using special triangles, going once, going twice. The only time a tangent could get a 1 is, or the opposite over adjacent equals a 1, is when both opposite and adjacent is a 1. When do you ever get a triangle like this? When the angle is pi over 4. So the related angle is pi over 4. Quadrant 1 and quadrant 3 is where they reside. So theta, so if we're dealing with quadrant 1, theta is going to be the same as the related angle. Sorry, not theta. So if in quadrant 1, angle beta is the same as the acute related, beta is going to be pi over 4. If we are, actually, I'm not going to write it there. I am going to write it underneath. If quadrant 3 is what we're talking about, beta would be pi plus the related acute, which is going to be 5 pi over 4. Okay, so let me highlight this while some of you are copying this down. If in quadrant 1 versus if in quadrant 3. All right. But please note, this question did not give us a specific domain as an interval. In fact, if I read this question, it says, write a general solution for the trigonometric equation. What does that mean? Well, I need an answer that covers every possible, potential angle. What that means is every coterminal angle with pi over 4. That is, right, where k belongs to integers. Same with 5 pi over 4. We have k, where k belongs to integers. And that's it. Except something has not yet been done. What does angle b? Angle beta is 2 pi. So if I substitute it in, beta, if it equals to pi over 4 plus 2 pi k, is the same as saying 2 theta is equal to pi over 4 plus 2 pi k. What does that mean? The angle is actually not pi over 4, but it's pi over 8. And every repeating pi. How the heck does that make any sense? Why would it repeat every pi when a full period is 2 pi? Well, Sam asked a really good question yesterday. What happens to that? And the idea is this. Take a look at the original question. That too represents a k value. It means that the ratio of old to new is 2. Long story short, a k value of 2 means my new period is a single pi. And do you see why that now makes sense? Originally, when we were dealing with beta, the coterminal angles were found by adding 2 pi. But in this particular case, one period is not 2 pi, one period is 1 pi. That's why we find all the coterminal angles of pi over 8 by adding just 1 pi. So if it was quadrant 1, it's actually this. That is my general solution. And if we are dealing with quadrant 3, beta was supposed to be 5 pi over 4 plus every coterminal of 5 pi over 4. But since beta actually represents 2 pi, theta is going to be 5 pi over 8 plus every pi. Okay, so put a little asterisk in it. Okay, I guess one thing that I could ask you to try to remember is if, right, your simplified solution has a double angle, okay, it is in your best interest to actually substitute it and solve it as you normally would so you don't get confused. Some people, if they do not substitute it and they keep 2 theta, they will probably solve this first. They will do this and they'll be like, oh, theta is equal to pi over 8 plus 2 pi k. And that is not true, right? Sometimes, anyways, take my word for it. I think the best idea is to remove the potential of making that mistake altogether. Once you get the hang of this substituting, you may not even have to do it. You can probably do it in your head and leave the 2 pi there all up to the very end after you calculate a general solution. Anyways, if the double angle 2 pi is there, sub in a, I guess, single angle until you find the general solution. Okay, that's my recommendation. At this point, that example is a little bit long and some people might still be following. Please check the time to see if a walk is necessary. I am going to move straight into example 5. This will be an opportunity for the substitute teacher to pause or explain anything if they feel comfortable doing so. You can pause the video. I'm going to clear in 5, 4, 3, 2, 1. All right, this is example 5 from the handout. And that is 2 sine squared 2x minus 3 sine 2x plus 1 equals 0. Ooh. All right. It might seem like it's complex, but for me, more than anything, I notice that there is a sine squared, there's a regular sign, and then I have a constant. That should immediately raise a flag and give you an idea of how it might be solved. Okay, what that would be is factoring. I'm going to let let's do the letter m. Okay, let m equal sine 2x. So if I sub it in, this becomes 2 m squared minus 3 m plus 1 equals 0, which, if you factor it, it becomes 2m, that's an m, negative 1, negative 1. I'm going to ask the substitute teacher to pause the video right now, and at this point, I feel like you might be able to solve to a certain extent. You might get stuck with the double angles again, but maybe you can use the previous example as a way to help you. Give it a shot. I am going to ask the substitute to give you maybe 2 minutes to try it on your own and get stuck if you get stuck. If you can solve it, great. Please pause the video. Assuming you pause the video and unpaused it now, I am going to move on. So this essentially turns into 2 sine 2x minus 1 and sine 2x minus 1, which means sine 2x is going to equal a positive 1 over 2, or sine 2x is going to equal a 1. Both values are possible for the sine curve. So let's get to it. Case number 1 is going to be this. Case number 2 is going to be this. Case number 1, which quadrant would sine, let's do A, equals negative 1b? It would be in quadrant 1 and 2. Okay, if sine A gives you a half, what would be the related angle? Well, you can calculate it. I've done this so many times. I know that sine of equaling half would have had to have the angle of pi over 6. All right, that means for quadrant 1, I have sine of A is, quadrant 1, angle A must be the related acute angle, which is pi over 6. If it was quadrant 2, angle A would be pi minus the acute related angle, which is going to be 5 pi over 6. Right? But again, don't rush it. You're not done. A couple of things. Because this is asking for all the angles involved in 0 to 2 pi, I don't know what that might be, but I do know that it's going to be coterminal with all angles that are sums or differences of 2 pi. In quadrant 2, this is also going to be 2 pi k. Remember though, A represents 2x. So 2x is equal to pi over 6 plus 2 pi k. Which means that is pi over 12 plus pi k. Next, since 2x is equal to 5 pi over 6 plus 2 pi k, x is going to be 5 pi over 12 plus pi k. I will highlight that just to add next there. All right. We're going to get back to this. Actually, I might as well solve it now. So x is going to equal pi over 12 plus pi k. Well, within the interval of 0 to 2 pi, that means it's going to be pi over 12 and 13 pi over 12. A single pi was added to it, becomes 13 pi over 12. If I added another pi to it, it would become 25 pi over 12, which is greater than 2 pi. So I don't have to go any further. X also equals 5 pi over 12 plus pi k, which means it could be 5 pi over 12 or 17 pi over 12. And nothing further because it has to be within 2 pi. The final answer is here. Let's pretend sine of b is equal to 1. Well, lucky for us, there's only one angle where sine gives you 1. So b would be pi over 2. But remember again, that angle is 2x equals pi over 2. Therefore, x is going to be pi over 4. Oops, I forgot, which means that's going to be pi over x. So x is going to be pi over 4 plus pi k, which means it could be pi over 4. It could also be 5 pi over 4. And it cannot be anything more than that because then it'll be greater than 2 pi again. So this question, as concise as it might have seemed, has 6 different answers. I have a feeling some of you are going to be watching this video once again. Okay? Final example. We're almost there. I will clear this video or clear the screen in 5, 4, 3, 2, and 1. Last example, example 6. 3 sine x plus 3 cos 2x equals a 2. Oof. Now I actually don't have my answer key in front of me, so I'm slightly going in blind. However, I do have some clues. Again, so something like this, it would be very challenging. It really would be. And, I'm just being extra, trying to get you to calculate angles that are in obscure things. You know what? We don't even have to go this far. For the sake of practice, let's just try to calculate just 0 to 2 pi. Okay? We can do harder domains when I come back. But for now, let's pretend it's just 0 to 2 pi. I have a cos 2x, and then I have a constant. So yeah, there's probably going to be some factoring. At least my first approach would be to factor. But sine and cos 2x, they are not the same ratio. So you might want to do something to change that ratio. And not only that, maybe it's nice to introduce a square, because if we have a square, then we have a polynomial, or a quadratic rather. Using the identity, if you recall, cos 2x is equal to cos squared x minus sine squared x. And there's my sine squared. And I'm going to actually rewrite this. This cos squared could be written as 1 minus sine squared x minus sine squared x. Oops. In other words, 1 minus 2 sine squared x could be substituted for cos 2x. So 3 sine x plus 3 times 1 minus 2 sine squared x. Somebody might be thinking, are you supposed to do that during a question? Well, no, I believe that this is given to you as an identity in your identity sheets. So you don't have to memorize how to do that. I just didn't have the sheet with me, so I just solved it myself. So we have 3 sine x plus 3 minus 6 sine squared x equals a 2. And if I bring everything to one side and rearrange it in terms of exponent powers or degree, I have this, and I have plus 1. Is this factorable? Multiplies to negative 6 but adds to a 3. I don't think so. So let's substitute it. Let's do capital A equals sine x. Okay, so it's negative 6a plus, a squared. 3a plus 1 equals 0. Can't factor, but it's too soon to say there's no answer. If you can't factor, you want to test it with the quadratic formula. So let's see if there's actual solutions. B squared minus 4 times A times C. Ooh, it is possible. All right, that means A must be negative B plus minus discriminant divided by 2a, so negative 12. From my calculators, that means the a value must be either a negative 0.2287 or a 0.7287. So it's possible. In other words, because of the substitution, what I'm saying is case 1, sine x equals negative 0.2287, and case 2, sine x will equal 0.7287. All right, let's do it. Sine x is a negative. That means I am dealing with quadrant 3 and quadrant 4. Also, the related angle, if sine x was equal to a positive 0.2287, the radian would be 0.222307. Okay, that means in quadrant 3, my angle is pi plus the acute related. So pi plus 0.2307 is going to be approximately 3.3723 radians. In quadrant 4, oh yes, it would be, plus 2 pi k, but we only have to worry about 1. So we don't have to worry about that. It's just going to be just 3.3723 radians. Quadrant 4, that is 2 pi minus the acute related. So that would be 2 times pi minus 0.2307, giving us approximately 6.0525 radians plus 2 pi k, but I don't have to worry because I'm only dealing with one circle. All right, there's 2 answers right there. If sine x equals to 0.7287, well, it's a positive. So I would be dealing with quadrant 1 and 2, and my acute related angle would be 0.7287. It would be 0.8164. Quadrant 1, the angle in question is equal to the acute related. So that's just 0.8164 radians, plus 2 pi k, which I don't have to worry about. And quadrant 2, the angle is pi minus the acute related, which is pi minus 0.8164. That is 2.3252 radians. That's it. Well, I say that's it like it was the simplest thing, but it's going to take some time getting used to. The example 6 is particularly difficult because it does involve a trig identity, but please don't shy away from that. You've had plenty of practice with trig identity, so I know you can do it. At this point in time, it means all the questions in the previous handout that I gave you yesterday, the exercise questions, all questions now on that sheet are open to you. I hope you'll get a chance to try those questions along with the textbook questions I've assigned at the bottom of the sheet, of the handout that I gave you. That's page 287, numbers 7, 9 to 11, 14 to 17, so on and so forth. Yeah. I will keep myself tethered to my phone so that if there are any questions, you can try it out. The rest of the class will be free for you to practice. Know that the next day you do have a mini test or rather a quiz. It's going to be 1 page double-sided. And then we will continue with just a small introduction to chapter 6, which is basically a review of grade 11 tomorrow. Again, if you do have questions about the quiz, please feel free to email me. I'll do my best to get it back to you before the night is done. And yeah, study hard.